Okay. And from that, we're going to start at the square root property. Which is state if you have, let's say, x squared equals some constant, we'll call it c. Then if you square root both sides, square root of x squared, and we clean that up a little bit. So the square root of x squared is going to equal plus or minus the square root of c. And since the square and the square root cancels out, that means x just equals positive or negative square root of c. So, for example, if we wanted to solve x squared minus 12 equals 0. Okay, so the first thing we want to do is get our squared value by itself. So x squared minus 12 equals 0. Add 12 to both sides, where those two would cancel out. So we're left with x squared equals 12. Okay, now if we use the square root property, just square root both sides. So x equals, put that a little too soon there. Positive or negative square root of 12. Okay. Now, since we know that 12 equals 4 times 3, we can make our x equals positive or negative square root of 4 times 3. And we already know that if we get square root of 4 times 3, we can just separate it into square root of 4 times square root of 3. Okay, so this just becomes plus or minus square root of 4 times square root of 3. Okay, and we also know that square root of 4 is just equal to 2. So you have plus or minus 2 times square root of 3, or just 2 square root of 3 as your final answer. All right, any questions on that one? All right, like I said, some of this should look a little familiar from Math 1000. This is more of a brush up more than anything. Okay, leave that up for a few seconds. All right, so for our next example, what if we wanted to solve x minus 1 squared equals 16? Okay, so we have our x minus 1 squared equals 16. Our squared value is already by itself, so we can just square root both sides. Okay, so the square and the square root will cancel each other out, so you're just left with, don't really need the parentheses, x minus 1 equals square root of 16, so it's plus or minus square root of 16. Okay, so we know the square root of 16 is just 4. So in this case, it would just be plus or minus 4. And then we add 1 to both sides. Okay, so that gives us x equals, the plus or minus doesn't go anywhere. That stays right there. So it's just 1 plus or minus 4. Okay, so that means you have two answers. You have x equals 1 plus 4 or x equals 1 minus 4. Okay, so for this one, draw a little separator there. X equals 1 plus 4 just means that x equals 5. Or x equals 1 minus 4 means x is equal to negative 3. Okay, so either one of those will make those true. Will make that problem true. Move that up a little bit. There we go. Okay, so let's say for the next example, we wanted to solve 3x plus 8 squared minus 6 equals 0. There we go. Okay. Now, the first one, the squared value was already by itself, so you didn't have to do anything. With this one, you have to get the squared value by itself. So that means you have to get rid of the 6. So 3x plus 8 squared minus 6 equals 0. We just add 6 to both sides. Okay, so now we have our 3x plus 8 squared equals 6. Okay, so now we go ahead and we square root both sides because we have to get that squared value by itself. Okay, so once we square root, the 2 and the square root cancel each other out. So you're just left with 3x plus 8 equals plus or minus square root of 6. And you can't really simplify square root of 6 any more than that, so you can leave it just the way it is. So now to solve for x, we go ahead and add 8 to both sides. Move this up a little bit. Okay, so now we have 3x equals 8, because remember that plus or minus doesn't go anywhere. So you do 8 plus or minus square root of 6. Okay. Yes? Oh, yep, thank you. It's me not paying attention. So it's negative 8. Okay, so now you just divide everything by 3. Where anything divided by itself is 1. So you have x equals negative 8 over 3 plus or minus square root of 6 over 3. Or if you wanted to, since you have the same denominator, you can make it negative 8 plus or minus square root of 6 all over 3. So either one of those would be okay. All right, so any questions on that one? All right, I'll leave that one up for a few seconds. All right. So now we're going to go ahead and go into completing the square. Okay. For completing the square, you want to remember your perfect square trinomials. That's kind of the key to completing the square. So that's a plus b squared is equal to a squared plus 2ab plus b squared, and a minus b squared is a squared minus 2ab plus b squared. So for example, if you have x squared plus 10x plus 25, that's just x plus 5 squared. Now to be completing the square formula, to complete the square of, let's say, x squared plus bx. Just those two terms. You want to turn that into a perfect square trinomial. Then you want to add and subtract. Or actually make that an and there. The square of 1/2 the coefficient of x. Okay. Oh, let me clean that coefficient up a little bit there. In other words, you're completing the square is just b divided by 2a squared. And a lot of times, instead of completing the square, you'll see me just write out CTS. Okay, so let's say for a quick example, we want to complete the square of x squared plus 14x. Okay, now for this one, for x squared plus 14x, we know our a is equal to 1 and our b is equal to 14. Because remember, it's in the form x squared plus bx. Okay, so that means for us to complete the square, remember that's b divided by 2a squared. Okay, so if we plug in our b and our a, that's just 14 divided by 2 times 1 squared. So 14 divided by 2, 2 times 1 is just 2 squared. And 14 divided by 2 is just 7. So you have 7 squared. Now before you apply the square, you want to remember this value. Because we know it's going to be 49. And that's the value you're going to add and subtract. So add and subtract this value. Okay. Now once you do that, this right here will now become x squared plus 14x plus 49 minus 49. Okay, so technically you just added 0. Okay. Now to turn that to complete the square, you're just looking at those first 3 terms. And the reason I wanted you to remember that is because once you get those first 3 terms, they just become x plus 7 squared. Okay. Now when you're asked just to complete the square, all they're looking for is that right there, so you're kind of ignoring the minus 49. This is really all they're looking for when they ask you to complete the square here. Okay. And the reason, like for this one, it wouldn't have been too bad to figure out that it's x plus 7 squared, but you'll get some there where you wouldn't want to have to try and figure it out. It's easier when that answer is right in front of you. Let me move that up some. right, so any questions on that one? All right, leave that up for a few more seconds. All right, so for our next example, let's say if we want to complete the square of x squared plus 7 over 3 times x. Okay, so let's say we have our x squared plus 7 over 3 times x. We know here that our a is equal to 1, and our b is 7 over 3. Okay. Now when you have fractions, a lot of times I rewrite it to make it look a little bit different, because remember, our completing the square, the formula is b divided by 2a squared. Okay. So our b is 7 over 3. So really this is 7 divided by 3 divided by 2 times 1 squared. Okay. Now if you wanted to, you can go ahead and rewrite it as 7 over 3 divided by 2 squared. Or instead of 2, you can make it 2 over 1. Just remember that 2 is equal to 2 over 1. And you remember your rules for dividing fractions. You write down the first one, change division to multiplication, and then you just flip the second one. So that 2 over 1 becomes 1/2 squared. So that becomes 7 times 1, which is 7, 3 times 2, which is 6, squared. So you have 7 over 6 squared. And before you apply your square, you want to remember this value, because that's going to give you your perfect square. Okay, so this gives you 7 times 7, which is 49, over 6 times 6, which is 36. Okay, so that's the value you're going to add and subtract. Okay, so we have our x squared plus 7 over 3x plus 49 over 36 minus 49 over 36. Okay, so really we're just looking for our perfect square trinomial, which is that. Okay. Now trying to figure out the perfect square trinomial there could be a little bit tricky because you got all these fractions, but you really just have to remember that value. Once you remember that, that's going to tell you what that perfect square trinomial is going to be. So this is just x plus 7 over 6 squared. And that would be your answer. So that's why just before you apply that square, you want to remember that value. Does that make sense? All right. So bring that down a little bit. All right, leave that up for a few more seconds. All right, so now we're going to actually use completing the squares to solve. So steps for completing the square. Or just CTS from here on out. To solve, ax squared plus bx plus c equals 0. Okay. Now your first step, you have an either or kind of situation. If your a is equal to 1, then you skip the first step and go right to step 2. So this is kind of a 1a and 1b situation here. Okay. So if we know that a is equal to 1, you just go to step 2. Okay. Now if this a in front of the x squared is equal to anything other than 1, then we're going to divide everything by that value. A doesn't equal 1, then divide every term. Clean up that e a little. By a to make the coefficient of x squared equal 1. Okay, so basically that just says that if a is equal to 1, you're good, just go on to step 2. If it doesn't equal 1, then we just make it equal 1. Okay, so the next step is you want to isolate all the variable terms to one side. So whatever this constant is here, if this is plus 8, then you want to subtract 8 from both sides. You just want these two on one side. Isolate all variable terms. To one side. And non-variable terms, which is just a fancy way to say constants, to the other side. Okay, so if your x terms to one side equal sign and your non-x terms to the other side equal sign. Okay, now once you have your ax squared plus bx on one side, then you just complete the square. And once you do that, you're going to add that value, which is b divided by 2a squared, to both sides of the equal sign. Okay. Now this step here should give you a perfect square trinomial. Okay. And your fourth step is now you're going to use the square root property to solve for your variable. And one thing you don't want to forget, which is really easy to forget, is your plus or minus sign. And your last step is check if you want to by plugging in your answers, and that's optional. leave that up for a few more seconds. Oh, bring that up a little bit. Oops. Alright, so let's say, for example, if you want to solve x squared minus 8x minus 5 equals 0 by completing the square. Okay, so we know for this one, x squared minus 8x minus 5 equals 0. We know our a is equal to 1. And our b is equal to negative 8. Our c is equal to negative 5, but it don't really have anything to do with our formula, so you can identify it if you'd like, but you don't really have to. Okay, so remember our first step. In this case, our a is equal to 1. So we just go right on to step 2. Okay, so our second step, remember, we have to isolate our x terms. So our x squared minus 8x minus 5 equals 0. We're just going to add 5 to both sides, where that disappears. So that means we have x squared minus 8x equals 5. So we isolated our x terms. Okay, so now for our third step, we're going to complete the square for the left side. Okay, because remember that's b divided by 2a squared. Our b is negative 8. So that's negative 8 divided by 2 times 1 squared. So really here we have negative 4 squared. Okay, and remember, before you apply that negative 4, you want to make sure you remember this value. Apply the squared. And we know negative 4 squared is just 16. Okay. Now, if you remember before, when we were just finding to complete the square, we just added and subtracted. But whenever you're solving an equation and it's equal to 0, you want to add this to both sides of the equal sign. Because remember, whatever you do to one side, you have to do to the other. And really, if you wanted to, you could still add and subtract it. So I'll do that just kind of as a little side here. So if you did add and subtract it, you would just have x squared minus 8x plus 16 minus 16 equals equals 5. And then you'd end up adding it to both sides anyway. So really, you're kind of skipping that step and just adding it to both sides of the equal sign right from the beginning.